Since the beginning of time, man has had curiosity. That curiosity has driven all of humanity to new lengths. In 2016, NASA announced that they were sending 4 people to Mars. But there was just one problem. How do we get there? Mathematically. In this video, we will explain to you how to get to different planets, factoring in their gravitational forces, their pressure and their oxygen levels per square metre. We will also show you the distance between both planets plus orbital patterns.
To calculate how much you would weigh on Mars, you need to use Newton's gravitational law. It is force equals gravitational constant, which is planet's mass in kilos, times your mass in kilos, divided by distance between the planet's radius, or F equals G, opening bracket, uppercase M, lowercase m, divided by R squared. If we take this into account, a 70-kilogram person would weigh a mere 5 or 6 kilograms if she/he was sent to Mars. Let's get into the serious stuff now. We should calculate the pressure to start off. This would be calculated as the force of gravity divided by the surface area of the planet. These measurements for Mars would be force of gravity equals 3.711 meters per second squared. The surface area would equal 144.8 million kilometers squared. This equation with these two measurements is written as 3.711 divided by 144,800,000, which would equate to 2.56 times 10 to the power of -7 psi, which is pressure per square inch.
Earth's measurements in this case means that the force of gravity would be 9.087 meters per second squared, and the surface area would be 510 million kilometers squared. Using the same equation, it would equate to 19.2 times 10 to the power of -8 psi, or pressure per square inch. This is a major change in pressure. We probably wouldn't survive it.
Don't be ridiculous. Now for the oxygen levels. At sea levels, Earth's oxygen levels equate to 2.5 times 10 to the power of -25 per square meter. On Mars, oxygen levels are almost 93% less, meaning that we'll get a small 7% of our normal oxygen intake.
To figure this out, we had to research and to compare Earth's and Mars's oxygen levels. Then we divided them by each other and multiplied them by 100, giving us a percentage. Finally, we need to take into account the distance between these planets, plus their orbital patterns. The distance between Earth and Mars averages at 225 million kilometers away, with the furthest distance being 401 million kilometers. Also, Mars only aligns with Earth every 2 years, 1 month and 18 days. It also takes a modern-day, currently used manned spacecraft 260 days to get to Mars when it's at its closest.
This means that the 4 people going to Mars have to live on limited oxygen levels and live in a cramped space for almost 2/3 of a year.
Therefore, we have deducted that humans would barely be able to survive on Mars without futuristic technology.
It is evident that one day we'll get to Mars, but for now, let's just explore what we already have and go to Mars once we know how to live there. Also, 260 days on a spacecraft. Imagine the jet lag.
In conclusion, we as a group would like to thank you for listening and watching our video on
The Race to Space.